Hello everyone, I'm Kavya from CSC department. In this video, we are going to see about what is feature selection, why do we need feature selection, and the methods used in feature selection. So feature selection is the process of selecting the most important input variables for a predictive models. So it helps to improve model accuracy, reduce overfitting, makes model simpler and faster. Why do we need it? Imagine you are cooking. You don't need all the ingredients in your kitchen, just the right ones for your recipe. Similarly, in machine learning, too many features confuse the model, increase computation time, lower performance. So we need feature selection to reduce overfitting, improve accuracy. More about feature selection, let's go into code. So first we are loading the data set. Here we are loading high-risk data set. High-risk data set is an built-in data set in scikit-learn which contains 150 samples of flour that has 4 features and 3 targets. Let's go into the code. So the first line denotes the function loads the iris data set which is preloaded in scikit-learn. In the next line we are importing the pandas. Pandas is used for data analysis and manipulation. So in the next line we are loading the data iris data set and stores stores in the variable iris. So the result is so in the third line the result is a special bunch of object containing iris data, the features, iris target, the special labels and iris feature name, column names for features. In line 4 we are converting the raw data which is iris data into a pandas data frame. Then now X holds the input features in a clean table format. In line 5 we are storing the target or output values in variable y. In line 6, we are printing the first 5 rows of the feature matrix, which is helpful for understanding what the dataset looks like. In line 7, we are printing the first 7 target lines. In summary, here X shows the data frame containing 4 flour measurement, Y shows the array containing target special labels, iris dot feature name is a column name used in X, and iris dot target name is an optional part. In feature selection, we are using 3 methods, namely filter method, wrapper method, embedded method. The first method used in feature selection is filter method. So filter method for feature selection in machine learning is used by ANOVA F-test with select k best. So in the first line, the select k best defines a feature selection method from sklearn that selects the top k features based on a scoring function. So f underscore class defines the scoring function used here. It computes the ANOVA f value between each feature and the target. In the next line, selector function, we are creating a select k best object named selector. Your K2 means we want to select the top 2 features that have the highest F score. In line 3, we are fitting the selector to the data X and target Y, calculating the F score for each feature. Transforms the data X to keep only the top 2 features. Now X underscore new contains just the 2 best features selected from the original dataset. In line 4, X and X dot columns applies that mask to get the names of these selected features. In line 5, we are just printing the final result. In summary about filter method, this block selects the 2 most relevant features from the dataset based on how well each feature separates the target classes using ANOVA F-test. So the second method used here is wrapper method. In wrapper method, we are using RFE. RFA defines recursive features elimination. So it is a wrapper based feature selection method. It trains a model, removes the least important feature, repeat the process until the desired number of feature is left. So let's go into the code. In line 1, we are importing the RFE recursive feature elimination class from sklearn dot feature underscore selection. So RFE is used to select features by recursively removing the least important one based on a given model. In line 2, we are importing the logistic regression model which will be used as an estimator for RFE. You can also use another models like decision tree SVM, but logistic regression works well for classifications. In line 3, we are creating an instance of the logistic regression model. Here max underscore ITR is equal to 1000, which sets the maximum number of iteration the model will run during training. This prevents error if conversion takes place. In line 4, we are creating an RFE object named RFE. It uses model logistic regression to rank features based on importance. It selects only the top two features. In line 5, we are fitting the RFE selector to your data, which is x is equal to features and y is equal to target. Here, what happens under the hood? We train the model on all features, removes the least important one, repeat until only two feature remains. In line 6, the result is listed, which denotes the top two selector features. In line 7, we are printing the feature name selected by RFE. So in summary, this code uses RFE with a logistic regression model to select the two most important features from the dataset by recursively removing the least useful ones. The third method is embedded method, which is also called as random forest. So random forest is a tree-based model that automatically computes feature importance as part of the training process. This is called an embedded method because it happens inside the model training itself. So let's go into the code. In line 1, we are importing the random forest classifier from sklearn. So random forest is an ensemble model that combines multiple decision tree to improve prediction accuracy and control overfitting. In line 2, you can add parameters to create an instance of the random forest classifiers. In line 3, we are training the random forest model on the dataset x is equal to feature matrix and y is target labels. During training, random forest learns how important each feature is based on how much it helps split the data in decision tree. In line 4, after training, this line extracts the importance score of each feature. So higher value means the feature contributes more to make good split in the tree. In line 5, we are converting the importance score into a panda series for better visualization. Here sort feature is used for most important to least important feature. In line 6, we are printing the final result, a ranked result of a feature name and their importance score. On summary, here we are using random forest classifier to create the model, fit x comma y to train the model, feature importance to get each feature contribution, and pd.series display nicely ranked features. So this method is automatic, powerful, and works well for non-linear complex relationship between features and targets. On conclusion, feature selection improves accuracy, speed, and interpretability by choosing method based on dataset size, model, and complexity. It is essential step in building effective ML models. Thank you.